We hired outside consultants. This is a tough question, and it remains a tough question. I'll talk a little bit about our insight. We even asked Watson, and Watson didn't know. And then one night I had a sobering thought. I actually know exactly what this technology is worth. It's worth the amount of money you can win on Jeopardy until they kick you off. That's sobering because that's what the technology does. We had some data points. Ken and Brad both won over $3 million. So we had a starting point. We had a high water mark. Unfortunately, Dr. Ferrucci and team spent significantly more than that developing the technology. But we started on the right foot. We won $1 million playing Jeopardy. Unfortunately, they gave it away. So Dr. Ferrucci is not responsible for our commercialization efforts, despite the fact that he took my suit coat and thinks he is. Seriously, since I was at the Singularity Summit, I was asked the question, do I think Watson is smarter than a human being? I have absolutely no idea. I don't even care. I'm thinking about the practical applications of this technology. In some ways, clearly, we demonstrated that in a particular application, the technology performs well. In other places, it doesn't perform well. We're not trying to replicate human knowledge, or I'm sorry, human behavior. We're trying to solve problems. And when we think about commercializing this technology and why we're excited about it, I think about four things. The first is we have a technology that's able to understand ambiguous human language. And I don't mean a small question. I mean an inquiry from a human being. And I'll talk more about that in a second. That's a big deal. I know lots of people who have trouble with that. Right? That's a big deal. Right? The second one is computers, and it's obviously an excellent use of computers, are able to read and ingest effectively limitless volumes of information, structured and unstructured. And they tend not to forget. So that's good. The third thing about this technology, and it might be the most compelling aspect of all, is that Watson returns confidence levels. It returns what I think of as an opinion, an evidence-based opinion. David calls them answers, responses. But they're confidence-based. It's quantitative measure with the evidence of why. And that may be the single largest breakthrough in this technology. The technology meaning the system. It's actually, obviously, many technologies. That's cool. And the fourth thing that you know about already is it learns. It learns, given the right amount of training data, the system learns. So those are four things that get us excited. Right? Then we start to think about where to take this technology. There's four orthogonal issues that we think about. The first is time. It's going to take a long time, independent of domain, to help this technology mature. Right? The second thing is we need to find high-value problems. This is an expensive system. This is not something that runs on a laptop. Right? Someday, maybe. But right now, it requires a lot of compute power, a lot of memory, human beings to load text. We write annotators to parse text and expand the information. So it is a complex system. Therefore, we need to find big problems that warrant big solutions. The third thing is we need to find problems for which the solutions are generalizable and scale. Because we don't want to spend 2 years and end up over in the corner with a system and an application that only works for one or two cases. Right? And the fourth thing is we want to do something that matters. We have an opportunity to change the world. And that means a lot to us. It means a lot to Dave. It means a lot to me. It means a lot to the IBM company. Some of you may have heard we just celebrated our 100th anniversary. And there's a lot, it's a reflective period of time. And we did a lot of good stuff for mankind in the last 100 years. And we think Watson is the kind of technology that can make a difference. And I'll talk about where we're going to focus in a couple minutes, and you'll see that. So the question is, what kind of problems are we looking for? Where should we apply this? We've got limited bandwidth. We have to focus. We've had over 300 ideas brought to us. And I'm actually hoping that by talking a little bit today, a few more good ideas will come to us. Right? Because, as I said, this is not easy. It's not obvious. The ideas have ranged from, as you might expect, we have a lot of customers and clients around Wall Street and the financial services. Tell me which stocks to pick. You know, you know, I'm not sure I'd sell that technology. Right? We are in the business of serving our shareholders. But the reality is that's a tough problem, and it's a problem that has been worked on for a long time by some of the greatest analytical minds and the greatest analytical technology we have. It's structured, you know, structured data in general, and we're not sure that's a good use of the Watson technology. Right? Along the middle, we've had recommendations for legal applications that make a lot of sense. A lot of text, a lot of complex analysis, evidence matters, obscure opinions matter. Good, you know, good problem. Clearly a problem we can make a difference in. The problem is it's tough to extract value in the legal economic system. Everything is billed back. Time doesn't matter that much. So those sorts of problems are out there. On the end of problems that seem to make sense to us are problems that have to do with intelligence, right? I mean defense, you know, terrorism, intelligence sorts of things, customer service applications, teaching, education, using systems to make folks learn faster and better, right, more efficiently. Analyst sorts of applications. Anyone who's in a position to read and synthesize large bodies of information and make recommendations, maybe in the management of a portfolio, not the trading and purchase of stocks, but in the overall management, wealth management of a portfolio. Those sorts of applications make a lot of sense to us. Why? If I could summarize our analysis, we're looking for problems. We're looking for decisions made by human beings that are important and occur frequently. And not every second, but maybe every few minutes, several times a day. Important decisions that are made by human beings where there is a big gap between the information that the person uses to make the decision at the time and what's available in the world. What they use now and what's available if the human being were to be able to read everything known to man that was relevant and remember it. So we're looking for that gap. When a physician makes a decision on a diagnosis that generally means a lot to a person, it's virtually impossible for that physician to have digested everything about my patient history, everything that's ever happened to me, right? Everything that's in my labs, that's in my files, right? Everything relevant to this particular condition or disease that I might have. They just can't keep up. The journals, the clinical studies, the clinical data, tough problem. That's an example of a problem that matters, and the information gap is large. And the other cases I gave you, intelligent, you know, teaching is a different kind of thing. It's a constant learning kind of application, portfolio management, et cetera. So we're looking for the information gaps. And where that information gap is large and there is a preponderance of textual information, that's a better problem. When real-time response time is less important, that's a better problem. You know, sub-second hard, couple minutes, hour, better. Right? And we've got all the dimensions that matter. Right? But these are the kinds of problems that we're looking for. We're going to pick a few. The area we've decided to focus on the most is healthcare. I've been here only one day, but it's come up 5 or 6 times. Right? The U.S. healthcare system is broken. It's not going to get fixed easily. Many have said it's the biggest problem the U.S. faces. I happen to agree with that. It's a complex, multi-dimensional problem. It has to do with regulations. It has to do with incentives. It has to do with antiquated systems. It has to do with the way people do business. It's a tough problem. We think we can make a dent in it. We're not going to solve every problem with a Watson-type solution. But we are going to spend a lot of time building something we call Watson for Healthcare. So we're working on all these other areas that I've mentioned, but we're really focused on healthcare. In fact, I'm spending most of my time, and probably will spend most of my time, hopefully for the next 3 to 5 years, working on this. The technology needs at least two improvements. Dave referred to this stuff a little bit, and we're working on them. The first is the ability to take in what we call an inquiry, not just a question. So you saw some examples from Dave about how a question is parsed. Right? In real life, an inquiry is a lot more loaded than a simple question. For instance, when I ask a simple question like, what's wrong with me? Right? My back hurts, what do you think? Right? There's a lot of context that could be provided to the system. And that context has to do with, the full articulation of my present condition, probably some of my patient history, maybe some observations that the staff or the doctor made. So there's a body of information. A lot of that information is included in what we call the electronic medical record. Electronic medical record. EMRs are in use today in most major care providers. They are repositories of information. I mean, they're phenomenal if you spend some time crawling through them. Everything's going into the EMR. Most of the information in the EMR is not utilized. Why is that? Because if you printed it out, it would be 70 to 100 pages in most cases. Most of it's textual. The most valuable information in the EMR, I should be careful. Some of the most valuable information in EMRs is in what they call the doc's notes, the nurse's notes. Right? When you leave, they type up notes. Computers don't know what to do with that information. Watson knows what to do with that information. So imagine going from a simple question to an inquiry. Right? What's wrong with me? And here's a bunch of information about me. So we have expanded the system, we have this working already, to take in a large inquiry. So we don't talk about questions, we talk about inquiries. The second part of the technology that needs to be improved is what Dave referred to. In fact, we had a healthy debate at lunch about what we call the interaction model. Watson is fabulous at answering questions in 3 seconds when the money's on the line. Right? That's not the real world. The real world is, I give you a bunch of information, whether I'm a physician or an executive or a lawyer, right, or a person, a teacher trying to help you, right? I give you some information, and then they say, well, what about this? And did you do this? And what about, it's a conversation. It's a dialogue. So the Watson applications that we envision will be dialogues. Because I don't have to dump the information on my doctor and say, you got 3 seconds, what's wrong with me? Right? Now, there are some doctors who will say, very good. That's because the pay-for-service system stinks. But anyway, that's another issue, right? So we envision applications where there is an interactive model. And we're building something we call the interaction model. So Watson could take in information as much as is available at the time and say to a caregiver, based on what I've heard, here's some thoughts. Here's a disease that is consistent with those symptoms, but you didn't tell me anything about the person. Have they been to Africa lately? You're in the U.S. This is the disease that is native to Africa. I would never think of suggesting a diagnosis like that, but if you would tell me if they were African, maybe I could help. Right? Is this patient pregnant? That wasn't volunteered. That matters. Right? And on and on and on. You can think of countless examples. Dave is actually fond of offering real-life examples of interactions with doctors where, 10 minutes, 12 minutes, go home, talk to the family, think about things for an hour, and then there's a whole bunch of insight and information that would be wonderful to tell the doctor. But it didn't fit in the 10-minute window, I didn't think of it. Right? So we think of an interaction model. And, it's okay to have 4 or 5 interactions. It's about getting to the best answer. So we are focused on healthcare, and what we call Watson for Healthcare is a service. So we are not going to take this code, which is massive and not quite ready yet, and throw it over the wall to every care provider in a large hospital and say, here, go develop some applications. Never get there. Right? And we've had conversations with all. I've met with almost every major care provider institution in the U.S. Over the last 15 months. I've met with over 300 doctors, and I've met with many of the purveyors of health plans. the other folks involved in this discussion. And they're excited. They're very excited. And they've asked us to build a system where we can create the repository for the industry, because it's a big investment. So we're licensing content, getting clinical data, and licensing journals, and licensing textbooks, and scouring the web. We're building a huge repository. It'll never be done, right? And that repository is the evidence base against which these applications will run. So our partners are developing solutions. The bread and butter of these solutions right now look like patient inquiry, workup, diagnosis, treatment. Patient inquiry, I tell the system about myself. Workup, the caregiver staff takes that information and in a continuous fashion expands it, brings in the EMR. Diagnosis, interaction with the caregiver staff, treatment recommendation. That's sort of the core. We have 20 use cases, quite frankly. I've just described the 4 that go together in what I call the breadbasket of medical care. Right? But this is what we're doing. We're working with large care institutions, starting with particular disease states, and they've volunteered to give us all their data and to work with us to bring their domain expertise. IBM's not a healthcare company. We'll never be a healthcare company. But we're working with leading healthcare providers to develop applications that will help caregiver teams, not just physicians, caregiver teams. 75 to 80% of caregivers are not MDs, right? And those caregivers, nurses, nurse practitioners, lay caregivers, et cetera, spend a lot of time with us. I was having a debate with a doctor about this, and it occurred to me, the doctor, of course, didn't need this system that much because, he had 15 years of medical experience and went to medical school. And I finally said, we're not building it for you. I get it. You're perfect, right? Right? Not everyone went to medical school, and not everybody has your experience. And he said, yeah, right? Oh, but I want to use it. So I think that's the reality. That's my guess at what's going to happen, right? So we are building these applications in concert with large care institutions, some brand names that you know. We'll pilot these solutions next year. It's going to take time. The payers, the health plans, are crucial in this, and some of the leading ones are on board because they pay. So imagine a scenario one day when you go in. Here's a scenario, and then I'll slow down and we can take some questions. You access a web portal. It knows about you. It's got some history, personal, obviously, personal private information. And you present your latest condition and complaint. Right? The system says, here's some thoughts. You're probably okay. Here's some thoughts. You better schedule an appointment. Here's some thoughts. Let me connect you to your doc, to the particular person for a conversation. The staff brings you in. That information is not lost. It's augmented with your longitudinal patient record, which means it doesn't forget anything about me, and I don't fill out the stupid forms every time I go in. And the caregiver team has some interaction with me, and somewhere along the line, they form a diagnosis based on recommendations from Watson. And the doc gets involved and thinks about treatments, and the doc has recommendations on what the proper treatments are, evidence-based recommendations on what protocols make sense for me, for my condition. Right? And the health plan is wired in. So what's called health plan policies, which are what you know as what insurance companies will and will not pay, right? Those are health plan policies, are married to care consideration guidelines. 90% of the time they're right. That's why stuff gets paid automatically, right? Sometimes they're not. But imagine a single vision or a single view of evidence-based treatment protocols, such that when your doctor says, let's do this, it's approved. It's done. Right? This is what the health plans are after. They're after lowering the waste, getting rid of the waste in the healthcare system. They're after better outcomes, evidence-based medicine. So that's what we're doing. That's where we're focused. We'll spend next year doing some pilots with these companies in particular disease areas. In 2012, I hope to bring out solutions to the marketplace. And at the same time, we'll probably expand into some of the other areas as the technology matures a little bit. Someday maybe, as the technology gets more efficient, maybe we'll all have a baby Watson. You know, maybe we'll shrink it down and we'll get it into a reasonable sized box, and we'll all be able to, you know, to answer our questions and to apply these technologies to other areas. But for now, it's going to take us a while to get some of these, you know, to get after some of these big problems and to try to help this technology mature. So I'm going to stop. We have 9 minutes, if this is correct. I'm going to invite my colleague, Dave, with my suit jacket, to come out, and perhaps we can take a few questions.
The clock is right. We've got about 9 minutes, so let's start over here on the left side, right on the aisle.
I'll moderate who takes them.
So several of the speakers in the past 2 days have talked about the fact that technology has become less a part of the popular culture and people ask fewer deep questions about the future. And I was just curious, do you have any plans? You know, I think the Watson moment with Jeopardy was one of the few times recently where deep future technology was really brought into popular culture in a big way. Do you have any other plans of doing stuff like that, where it's more about evangelizing the technology instead of, you know, commercializing it?
So there's a couple of things that are of interest to me personally. I can't sort of dub them as legitimate plans yet, but I can tell you there's two topics that are of great interest to me beyond, you know, applying this to healthcare. And one is looking at this technology as a way to do much more efficient, intelligent tutoring. When we think about helping kids in, you know, reading comprehension, how to analyze text and make inferences and answer questions and getting them to think about what they're reading and the inferences they're making, I see a kind of a really cool application of that technology into that spot. And what I mean by more efficient is that, you know, currently those kinds of systems are highly scripted, and I think the potential of Watson is not to actually have to have them scripted. Watson can look at the text and the questions and actually do this more automatically without having humans have to script that. So I think that's really cool and exciting, and I think that has that similar kind of cachet. Another one relates to how do we teach Watson. You know, if you'd go with me on this, that I think Watson, at least with regard to human language technologies, is probably one of the most advanced systems on the planet. It still doesn't know everything. It doesn't know everything about language. It doesn't know everything about meaning, certainly. And through interactions, it can get smarter and smarter. And if we can, one of the things we're thinking about is deploying a class of crowdsourcing kind of thing, where if we get lots of people to interact with and teach Watson, we can very rapidly grow its capability. And, you know, if anything, that's one of the ideas that I find sort of analogous with the singularity concept is that you might see that exponential acceleration in its ability I don't like to understand, because I don't like to use the word understand, because I don't think of the computer really understanding things the way humans do, but that's a long-winded debate. But to be more effective in producing the meaning equivalence that humans would expect. That's sort of a more accurate way of putting it.
So to be clear, though, we are spending a lot of our time and energy commercializing and trying to find practical applications. So the research will continue, but we'll do both.
Next question, about 10 rows back, near the aisle.
Would it be possible to have Watson specialize, just like the diagnosis, or learning for individuals that need the different
Special ed would be one of those things that would be great. I don't know. We just haven't gotten far enough along to look at the kind of partners who want to help us bring solutions to market and what it means. So at this point, I don't know.
Over here on the left side, right on the aisle.
Hi, my name is Yuri. I'm a healthcare provider. My question is, will your system be limited by the results of evidence-based medicine in the U.S. as far as giving opinions to the doctors and compiling data?
The answer is absolutely not, right? So let me see if I can just clarify where we're focused right now. The system, and I can use this word that's not accurate, exactly accurate, but the system thinks in English, so to speak, right? So these ambiguities of English language that we still have some work to do, and now we add medical jargon, right, is a hill we have to climb even further. The ingestion of the content, right now we're only looking at English language content, right? But those are worldwide results. Clinical results in Europe are just as relevant, in fact, sometimes more relevant, right? And the beauty of a system like Watson is it's able to, sort this stuff out and present evidence. So a preponderance of evidence and more data is good. So now whether we'll be deploying outside the U.S., I don't know yet.
But in a way, when you're talking about the payer system that occurs, that's really based on evidence-based medicine in the U.S.
That's correct. But that's not how the providers think. Right? Our customers are actually, healthcare providers. So complex issues. The payers complicate things, but they have the money, and we all want our care paid for. So.
Next question near the front here on the right side.
Have you approached Congress to streamline the decision-making process that this country needs?
You want to take that? I don't even know.
I haven't approached them yet, no.
Back to the left side, again on the aisle.
Hi. Is the language parser handcrafted, and did it trip up the engine when the question about the airport was asked?
Yeah, so great question. So the language parsing technology, one of the really remarkable things was having opportunity to do this at the IBM Research Labs, and we've had investments in many of these areas for a long time. One of them, of course, being deep natural language parsing, and we had a parser that was under development a long time. But as I said earlier, none of these methods are perfect, and of course it would get tripped up. But one of the approaches that we took was to look at multiple interpretations. So we had this expectation that none of these algorithms were going to be perfect, and we really deferred commitments, looked at multiple possibilities, and ran through the entire system and said, you know what, sometimes you'll have more evidence other than the parse that might support, an answer. And if through training we learn to value that evidence, that would overwhelm something that the parse might have confused. And this was a very powerful underlying sort of principle that we use, because again, none of these technologies are perfect, and the more context you have, the more evidentiary context you have, the better off. You don't rely on one algorithm being perfect. Future implementations may use not just multiple interpretations of the parse, but multiple parsers.
Next on the aisle near the back.
Isn't making the physician more efficient paving the cow path? Why not eliminate the expensive bottleneck, namely the physician themselves? Or replace them, I mean. Or is that too radical a departure from the status quo?
So as a patient and as a father, I'm not sure how comfortable I'd be with that. We're not after replacing physicians or caregivers. There are things that people do, like sensing my mood and understanding me, and making human judgments, deep human judgments that I trust, and I suspect it's going to be a few years before machines are able to do that. I don't know the upside of replacing well-trained physicians. I do see the upside in making caregiver teams have more time to spend with me and more data to help them make more evidence-based judgments. So I will tell you, worldwide, there are not enough physicians, and the shortage is growing. Right? In the U.S., we're actually a little bit rich. So I just don't see the upside of going after a problem like that. So.
Time for just one more right here in the front.
I'm Rick Schwal. If I understand what you said, there is one Watson application package that did both the job of reading mountains of text and then playing the game. Is there plans to have them done separately? That there's a text reader database loader and then there's a question answerer?
Yeah, when we talk about Watson, we talk about technologies with an S. And so
So there's an underlying architecture, and the way to think about the interface to that architecture is there's, Dan used the word inquiry. An inquiry could be a simple question. It could be a semi-structured graph of data, meaning a bunch of cues, a bunch of facts that are both in formal language or in textual language. And there's some unbound variable. In other words, there's an unknown entity. In the case of Jeopardy questions, it's like this province, this president, this whatever. In the case of medicine, it's this disease or this treatment. And what you're trying to do is bind that unknown entity, right? So this is the basic interface. The architecture goes off, takes that input information, generates many possible bindings, many possible hypotheses, collects the evidence, scores the evidence, comes back and says, here are the possibilities, here's the evidence that support those possibilities. That's the basic interface of the architecture. I can now deploy that in many different ways. Something that looks like the question answering system in Jeopardy, something that looks like a dialogue with a doctor. I could deploy it in many different ways. It's the same basic architecture in the back end. Has to be populated with different content and different algorithms, or more advanced or refined algorithms, same architecture.
That's all the time we have. Dr. David Ferrucci and Dan Cerruti from IBM, thank you very much. Okay, don't get restless. Don't get restless. We are not done. I've got a few important announcements, and then Ken Jennings will be here to speak to close the summit. If I could have your attention, please. I want to give one very important thank you to begin my few announcements here. That is for Amy Willey. She is the principal organizer of the Singularity Summit, and she's here to make a brief announcement. Please welcome Amy Willey, organizer of this year's summit.
Hi, I just wanted to thank everyone so much for coming and making this a wonderful summit. We had a great time. Also, the photos and videos will be available on the homepage in about a week. So, thank you again.
So I've got a number of people that I need to thank in addition to Amy. Before I do that, also one note. Earlier, a phone was found, brought to the podium. I asked if anyone could claim it. Someone did, and then somebody else thought it may have been theirs, and the whole thing may have been confused. So if you have a phone and it's not yours, either bring it to me or take it to the registration desk, and we'll get that sorted out. People that we really need to thank. Jan Tallinn, first of all, the sponsor of the matching grant. Jan and his firm, Ambient Sound Investments, sponsored this summit, and we cannot be grateful enough. Also, Rob and Oksana Berzel and Rob's firm, Talos Partners. Also, of course, Peter Thiel and the Thiel Foundation. And I believe there are still a few copies of Sonia Arison's book, courtesy of the Thiel Foundation. That's 100 plus in the lobby outside. Also, corporate sponsors, Cortical DB, DesignBank.org, and Rick Schwall of Saving Humanity from Homo Sapiens. And finally, PhysioAge. Thank you very much to all of our sponsors. If you would like to sponsor next year's summit, you can do that by getting in touch with Amy, and her email address, which she has authorized me to give you personally, amywilley@gmail.com. So you can get in touch to sponsor Singularity events in the future. We also want to thank the team. Lena Anderson has been taking care of AV on our side. Liz Bosselaar is our executive producer. Michael Anisimov, Luke Melhauser, and Kathleen Kilgallen have been instrumental in bringing this summit together over the last few days, and we've had lots of volunteers who have made important contributions. So thank you to the entire team. Finally, we want to thank the 92nd Street Y for being excellent hosts. Thank you to the 92nd Street Y and the entire team here. And I also want to note that next year's summit is already planned. I have the exact date. Give me a second to find it. It's October 13th and 14th, same time of year, in San Francisco. And the speaker list already includes Steven Pinker, who's just released a new book, Temple Grandin, who is famous for her revolutionary work in the livestock industry, and Ray Kurzweil. Next year's summit is shaping up to be just as good as this one's, and we hope you will be able to attend. Amy also invites you to email her if you have any suggestions for who should speak at next year's summit. Again, it's amywilly@gmail.com. And so with that, and to close the Singularity Summit for 2011, it is my pleasure to introduce Ken Jennings. Ken is a software engineer, an author, and a record-setting trivia game show contestant. In 2004, he demolished the previous record by winning 74 consecutive Jeopardy matches, before he was finally defeated on his 75th appearance. He has won more than $3 million on Jeopardy and holds the record for the highest total game show winnings ever. Ken has also authored 3 books. The first, called Brainiac, is about his Jeopardy experience and the broader world of trivia buffs. And his most recent, called Maphead, is about cardophiles, or as you may know them, map geeks. Early this year, he was chosen as one of 2 human contestants to compete alongside IBM's Watson on a special edition of Jeopardy. Watson won the match, of course, and earned Ken's respect for a feat long thought impossible for computers. Ken is here to reflect on his encounter with Watson and to share his thoughts on what Watson might mean for our economy and our society. Please welcome, to close the Singularity Summit, Ken Jennings.
Thank you. The mic's working, right? Excellent. It's nice to see you here. Thanks for sticking around to the end of the summit. I know it's been a long and fascinating one, but I'm happy to actually see people at the end of it. We have made it this far this weekend without the Singularity actually happening. If it does, I want to remind you there's emergency exits. The front and rear and sides of the auditorium, should the Singularity actually occur during my talk. I feel a bit outclassed here today after all the geniuses in their fields, the futurists and the technologists who have spoken to you. I'm a quiz show contestant. I feel a little out of place. I have a little bit of nerd envy in this room. If there is a nerd hierarchy, I don't know if Jeopardy champion is at the top of it. I'm pretty sure it's not. But I can share a fairly unique experience that I had earlier this year, which as you heard, was actually essentially losing my job to a computer, and a knowledge sector job, which you don't always see, and on primetime TV, which you don't always see, in very convincing fashion. I'm very happy to be back in New York. I was here, I don't know, 8, 10 months ago? When did we tape that thing? We taped the Watson thing very early this year in the winter. And Jeopardy normally tapes in Culver City, California. I had my routine down when I was on the show back in 2004 for 6 months or whatever it was. I would fly down from my home in Salt Lake City, play, as it turned out, 10 games each time over 2 days. They do 5 in an afternoon. As soon as you and Trebek can change your tie, you got to get back out there and play again. So I had a routine down, and if you want to win at Jeopardy, that's the secret. Arrange to play 75 times, because it becomes a summer job. You're going up against fresh meat every day, and you can just see their faces fall when you walk in. This experience with Watson took me out of my comfort zone in a big way. Watson does not travel. Watson's big. Watson's, I don't know, the size of an RV. Isn't that what they say? I don't want to get any of the details wrong with the IBM guys here, but Watson's big. The only Jeopardy contestant to date that I have actually been inside. With one exception. No, I'm just kidding. So it doesn't travel. We had to come to it. Instead of playing at a studio in Culver City, we had to come to the wilds of Westchester County, what seemed to me to be this very isolated, top-secret IBM research lab in the middle of a snowy woodland under very secretive conditions. It was very different than your average Jeopardy game. It was this beautiful old, I think, Eero Saarinen designed mid-century building with a few oddities, like Eero Saarinen, like great Finnish architect apparently, only put 2 men's rooms, I think, in this building. And one of them had been roped off for the contestants. Me and the other human contestant, Brad, had been kept carefully apart from anyone who might know any of the answers, who had worked on the team or worked on the computer or anything, for reasons of honesty as a security and whatnot. And Watson doesn't pee, so this only affected me and Brad. But they had walled off one of the, I guess, very few men's rooms in this building just for our use. And the Jeopardy staff pretty much spent the whole day yelling at IBM employees, including executives who were daring to try to use this men's room. They yelled at some guy, you can't go in there. And it turned out it was like his building, like he was the VP who ran the lab. And he was not being allowed to pee in his own urinal. So there are some privileges that money and rank cannot buy, I guess. There's no dressing rooms, of course, so instead of changing into, Jeopardy garb in a dressing room like I was used to, we were in some HR conference room. I left an apology to all the people whose desks my, bare butt has now had contact with, I guess. The game itself was also a little different. Watson can't see or hear, for example. So while it was a regulation Jeopardy game in almost every respect, there were no audio or video daily doubles. There were no categories of the type where Alex would have to explain the concept to the contestants because Watson would not have been able to hear the explanation or understand it, even if he could have, quite frankly. There was also the fact that for the first time, I was playing in front of a crowd that wanted to see blood. They wanted to see my blood. I remember walking out onto the set, and to get to the podiums, you had to cross a big Watson avatar on the floor. And I was totally picturing some basketball team having to walk across the Lakers logo as they walk onto the court. You could tell it was an away game for humanity. These were engineers that wanted blood. They had Watson signs, and every time their little darling got a question right, yeah, I knew he could do it. It was like Little League dads. It was like a room full of Little League dads, except their beloved little hitter is again a supercomputer the size of an RV. So it was tricky. I had first heard about this contest a year or two earlier. Jeopardy had called me, so it was exciting in the Jeopardy house, or in the Jennings house when Jeopardy calls. Also the Jeopardy house, since they paid for it. And they said, you're not going to believe this, but IBM wants to build a computer that can play Jeopardy. And my face just lit up. It was like the best thing I'd ever heard. Are you kidding me? There's going to be a robot on TV playing a game show? Truly, this is the future. It was almost as if they had called and been like, all right, the future is here. We're going to issue you your flying car and your jetpack and your undersea bubble city. I felt like the future was here. Robots were finally playing game shows, as I had always long dreamed. And they said I might get a chance to play it. I was excited. Let me see if the slides here work. They sent me one of the first journal publications about Watson, which had a image very much like, no. Is this not the right button here at the bottom? Hey! Maybe Dr. Ferrucci showed you one very much like this. This is just one I stole off the internet. I love graphs, and this was the first thing. So this was the first thing I saw in the paper. It looked very much like this. It measured Watson's confidence, I guess, in answering the question versus its accuracy on the other axis. And up there is what they call the winner's cloud. This is how winners have done on Jeopardy. And at the time, Watson was down here. This was not something that computers could do at the time a few years ago. And this was the first thing I thought. I had taken a couple AI classes in college, and I thought, AI's not there yet. I think I'm pretty safe. A computer cannot yet play Jeopardy. Little did we know this is what I'd be looking at a few years later. But there were two colors of dot at the top. There were the gray dots and the black dots. And I was like, why are there two? I can see these are human games, but what's the difference between the gray dots and the black dots? And I turned the page, and it says, the black dots represent Ken Jennings, the show's 74-time champion. And I remember just freezing, and sort of looking around and I realized this is what it looks like. This is what it looks like when the machines come for you, ladies and gentlemen. The gray dots are the rest of the human race. The black dots are you. Everything that you thought made you special, everything that you thought gave you your sense of self, everything that you thought separated you, not just from the apes, but from your laptop or your iPhone. And it was gone, There was a line that was trying to get up to that. And as we can see, by the end, Watson, spoilers, Watson wins in convincing fashion. By the end, Watson was clearly matching, the accuracy and the precision of top-level Jeopardy players, in some cases dwarfing their performance. I guess this was karma in a way for all the people who had to play me on Jeopardy and thought, this is not fair. Like, what's with this guy? He's been playing for weeks. He's faster than me on the buzzer. Seems like he knows all this stuff. Like, how is this fair that I have to play him? So I'm sure these people were very happily watching at home 5 years later as me and Brad Rutter are thinking, this is not fair. This thing's got like 15 terabytes of RAM. Are you kidding? Like, they're throwing millions of dollars at this thing. Like, we just like playing bar trivia. Like, why are we here? We're out of our league. One thing that I started to see after this was, and especially in the wake of the game, is just sort of the way public perceptions of AI are surprising. I think Dr. Ferrucci mentioned this. He referred to it as a polarized spectrum where machines are both much less sophisticated than the layperson might believe. Having been raised on fictional and science fictional versions of machines that quite easily talk to humans in natural language and answer their questions, for example. We think, well, that might be easy. Of course a machine can answer my questions. Captain Kirk's machine does that. Like, Hal did that, and we're 10 years after that. Google answers my questions. If I have a question, Google can answer it. Why is this hard for a machine to win at Jeopardy? And I think Dr. Ferrucci's explained, some of why that is. The things that Watson is good at that are surprising and new. One of the great things about being on Jeopardy against Watson was getting an email from Douglas Hofstadter, who had long been a idol of mine. When I was 5 or 6 years old, I remember my dad used to read to me the dialogues from Gödel Escher Bach as bedtime stories. So if you want your kids to be on Jeopardy, by the way, there you go. Gödel Escher Bach as bedtime story while they're in kindergarten. Never fails. So it was very exciting to hear from Dr. Hofstadter. And one thing he said was, what do you think about Watson? It's not really AI, right? I mean, and these are his words, if anybody from IBM is here. It's just like a glorified spam filter, right? It's really good at processing huge amounts of text. It sees patterns. It figures out which patterns are the helpful ones and which ones are not. And it uses that to answer the question. It's the same thing the Google spam filter does, right? I was sympathetic to that point of view. When I first heard about the kind of brute force power that Watson has at its disposal, I was tempted to think that way as well. But then I started to hear more from the Watson team about how it does what it does, the kinds of process it goes through when it sees a Jeopardy clue. How it, the first thing it does is parses the question, tries to figure out which are the more meaningful words in the question, what's signal and what's noise. Trying to use contextual clues to figure out things like geography and chronology, gender, does my answer match up in all respects to the clues in the question about time and place and things. Are there multiple parts of this question I should be trying to solve in parallel and see if there's an overlap? Once I have an answer, how do I judge how confident I am about it? How do I double check it? My face sort of fell when I heard all this stuff. This sounded exactly like my process when facing a Jeopardy clue. This is the kind of thing a good human being who has been raised with Jeopardy in their blood does when one of those little white on blue clues appears on their TV. That's exactly your process. Some of it might be intuitive. Some of it might be under the hood. You might not always be aware you're doing it. But if you're good enough, that's what you're doing. I was pretty convinced. I felt this very strong, intuitive sense that Watson was sort of doing what I would do. It doesn't have a lifetime of memories of accumulated stuff to comb through, so instead it combs through a massive text bank. It's not cheating, though. That's just the closest equivalent it can do to what we do. I know IBM had tried, just to make sure that this was a hard, meaningful task of AI. I think they had some guy in a basement trying to solve this problem by cobbling together existing technology. And it couldn't do it. The existing technologies were way out of their league. They'd get a few questions right a game. Not enough to even stave off embarrassment, much less play a high level of player. And that's because Jeopardy clues are tricky. Natural language is a notoriously hard AI task, and Jeopardy clues harder than most. They're very short. They have to be compact. They're almost like a haiku or a villanelle or some demanding poetic form, just because there's so much going on in there. There might be misdirection, there might be hints, there might be red herrings, there might be double meanings, double entendres, there might be jokes, there might be sarcasm, there might be literary historical allusions that are related or unrelated to what ends up being the actual answer. It's a minefield if you're a computer. It's hard enough if you're a human. For a computer, it's a minefield. Those who watch the show at home may not realize, though, that Watson did have some advantages that human players do not. I sort of thought that buzzer timing would be an underreported, the buzzer skill would be an underreported part of the contest. And instead, it's the one thing I got asked about the most. Like, did Watson get the questions ahead of time so we could think about them before you could? And did it have to buzz in? The answer is yes. Watson saw the question at the same time we did, although it's getting it fed electronically, so maybe it has a bit of a head start. It doesn't have eyeballs to go back and forth like me and Brad did. Did it have a thumb to buzz with? Yes, it did. As I stood at my podium, Watson's right here. I could always tell when it knew the answer, because it had a little solenoid, and when it knew the answer, you'd hear this. So insectoid clicking. Very unnerving. You could sort of tell that if they slowed it down, it might sound exactly like the Terminator theme. Dun, 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 dun. And the fact is, I know IBM to this day is saying that the human players had a huge advantage on the buzzer. They can anticipate. Watson does not. Watson has to wait to be told to buzz. But the fact is, the humans who anticipate do so with a great degree of unreliability. They're a little too early sometimes. They're a little too late other times. Watson makes the exact perfectly timed buzz, probably down to the millisecond, every time that it feels like buzzing. And I don't think IBM had any idea how this was going to turn out against very good human buzzers. As it turns out, it is much better. Watson is hard to beat when it feels like buzzing. You can beat it on a fluke sometimes just by taking a stab at it, and maybe you'll get in the microsecond between it being told it's allowed to buzz and its little solenoid doing this. But you're probably not. And I say this from experience. If a human buzzes too early, they get locked out for a fraction of a second, and Watson wins. Watson also, in the televised match, got a little bit lucky with the categories it faced. Humans vary on Jeopardy skill in a couple ways. By category, certainly. A human might be very good at literature, but bad at television, or very good at rocket science, but bad at biology, depending on whatever the human's own interests are. The silicon-based player does not distinguish. Watson tends to be good or bad at a category just based on something that's hard to point out, how high concept it is, how much of a learning curve there is to understanding the category itself. Is it very straightforward factual recall? Or is there more going on? Is there a little narrative you have to learn to grok the category? Watson's much better at the former than the latter. Watson's also terrible at short clues, which I did not realize until we had a nice short category. It needs time to think. It needs the time of a dignified Canadian game show host reading through a question at his normal cadence in order to have time to process through and come up with an answer. So if there was a very short clue, Watson would often get beat by the human, even though it had the right answer eventually. You'd see the right answer appear on the bottom of the screen, after the human had already buzzed in. In some of our practice games, Watson got a few categories that were not to its taste. The day before we taped the televised match, we ran through a full practice match, and I actually won in, I think, what Jeopardy fans call a crush, having twice the opponent's score going into Final Jeopardy. The game is out of reach, by making the final question academic. In a practice game the next day, Brad actually won. But during the actual televised games, Watson happened to get, and I say happened to get because these were all randomly selected games that had been written for regular Jeopardy play. Watson happened to get categories that were its strength and did very well. So the computer is both more and less sophisticated than you might have thought watching on TV. The things it was doing was harder than the layperson might believe. It also got sort of lucky in some of the draw of what came up during that game. One thing I realized in the wake of the Watson game is that there's a challenge for AI that I've never thought of, which is the public relations challenge for AI. I think the Watson match revealed, and I don't know if IBM would be surprised by this or not, a vast public reservoir of bad will towards the idea of computers doing knowledge-like tasks. I was at a press conference with a few IBM guys where they were asked about the evil supercomputer that takes over, Tron or the Matrix or War Games or whatever. And they were quick to point out, no, it's Star Trek. It's the nice computer and the soothing female voice. where as soon as you need information, you just ask the ether, and the answer comes back and gives you exactly what you need, no extraneous crap. It filters out exactly what Captain Kirk needs at any given moment. That's what Watson is. It's not the evil kind. Somebody else asked about, like, so are there, like, Homeland Security applications for this? They're like, nope, healthcare. You might think this would be very good at, analyzing facial scans from airports or listening to cell phone chatter. No, it can't do any of that. It's for medical diagnosis. So, so obviously there. I don't know if this is a room full of tinfoil hat libertarian types. I myself am not. I think the point is any technology will have both, friendly and scary applications. But IBM, of course, was being very careful to spin Watson's media-friendly side. And yet, after the game, this was the kind of stuff we saw on the internet. It's me on the right. That's Brad. That is Terminator. Or, this was something an artist sent to me, evil, victorious Japanese robot in the middle. Hal, of course. I've always loved the fact that Dr. Frucci's first name is Dave. That must have been fun at IBM. This is a favorite of mine, ED209. Anybody know what this is? Robocop. Very good, yes. So I guess Watson will be in law enforcement. Look at that. So this was the public reaction, to make jokes. And maybe they're just jokes. Maybe this is because this is how the media has trained us to think of emerging technologies. It's dramatically more interesting if the machine goes crazy and kills us than if it politely answers all our questions, Captain Kirk style. But I think it's also a sign of something deeper in our culture, the fact that on some level we are awed and in amazement at technology and love the way it's improved our lives, and yet a lot of people are very scared by its complexity. This is your grandma who hasn't been able to change the channel since they put the cable box on top of her TV in 1987, like that was the moment when it got scary for her. And I think no matter what the technology is, we all have those, we all have those moments of when it gets too complex and we just think, is this really better? Like, 30 years ago, I could have gone into this business and asked them, why my bill is screwed up, and instead I'm on hold with like a series of recorded messages for like 20 minutes, like, how is this complexity helping me? And that's aside from economic effects. I am not an economist, just as I am not a futurist or a technologist. But I got a few more minutes, so I'll take a shot at this. I said that a quiz show contestant was the first job to be made obsolete by a new kind of thinking technology. I don't think it's going to be the last. I think I've done some reading, and there are people studying this. In general, we've always been worried about this in the past. The guy on the assembly line whose job is taken over by the robot, and an economist will say, in general, that's good. It makes the economy more efficient. Goods and services are cheaper, and everybody wins. Maybe it's a little bumpy on the way. I know there's a guy on MIT who thinks this might be different. New kinds of technologies might need new challenges. He calls it job polarization. If machines that can answer simple questions like this start to take over these middle-skilled jobs, whether that's a lab tech of some kind, or a pharmacist, or tech support, or a paralegal, all the things where you're people who are supposed to scan text and produce signal out of noise. If all that stuff goes away, you're sort of left with low-skilled, low-paying jobs over here, high-skilled, high-paying jobs over here. And in a time when the middle class is already struggling, have we lost something valuable by losing these middle-skilled jobs to again, ED209? I don't know, but I think it may be sort of rocky as we try to find out. As whole industries disappear, whether that's pharmacists or even lawyers or journalists. There are now programs that very much simplified Watson-like programs that can cobble together news into new content, and sites on the internet looking to produce content no longer have to hire humans to do it. It's already a crappy time to be a journalist, and now you have to fight against a robot too. Jeopardy style. So it's something to be aware of. The danger that I think about more, because again, not an economist, not a futurist, not a technologist, but I am sort of an expert at knowing weird stuff. Like I might be the only person in America that puts quiz show contestant on his tax return. And as I said at the beginning, I've always felt that this is sort of what has distinguished me. This is the one skill that made me a special little snowflake, was that I could sit on my couch and through a mouthful of Doritos, yell out answers at Jeopardy, and very often they'd be right. And now that's still true, but much more often and much faster on the clicker, the computer is right. What does this do to us? I sort of worry about outsourcing parts of our brain. Maybe this is a room full of transhumanists and they think this is awesome, that someday our brains and our machines will work together in some glorious synthesis. But just like the economic change, it's going to be rocky on the way. Maybe it'll be harmless. Like, I don't know anybody's phone number anymore, I have a little device in my pocket that remembers phone numbers for me. And the part of my brain that used to be good at remembering 7-digit numbers now no longer functions, and I don't even know my wife's number. So that's a harmless change. This turned out to be much better at remembering phone numbers than I did. So, one for ED209 here. But there are other skills. I just wrote a book about maps and geography. And the dawn of GPS was sort of an interesting subject for me. They've done neural studies of the brains of people with good senses of direction. They did this on London cab drivers before and after they passed a test called the Knowledge. Maybe you guys have heard about this. To have a London cab license, you have to pass the Knowledge, which is this very notoriously difficult and detailed test of London street knowledge. So you always know which way to turn. And when they did scans on these cabbies before and after, they found that the brain had physically changed. The hippocampus, like the Grinch's heart, had grown 3 sizes. While these guys, while these guys were in the process of learning London geography. The brain actually changes as we get better at things. And I was reading a scientist in Quebec who thinks she has seen the opposite effect. The hippocampus is starting to atrophy as people rely on GPS. They're no longer trying to use their innate sense of direction to figure out where to turn. Am I too far north of the place? They're certainly not pulling out maps from their glove compartment and trying to figure out where they are anymore. These are skills that we have decided to outsource to a little talking box on the dashboard, for better or for worse. And if you've ever read any of these news stories of people turning onto railroad tracks or driving into the ocean or whatever because the little talking box on their dashboard told them to, sometimes for better and sometimes for worse. And I'm part of the problem. I have one of these on my dashboard. My kids love it. We call it Daniel because that's the name of the British accented voice we chose to use in exchange for the sort of judgmental sounding American woman that's the factory default. Jill. I hate Jill. Anybody? Do you guys have a Garmin? I hate Jill. Recalculating. Like I've inconvenienced her, Anyway, so the kids love the GPS. It's part of the family. But I do worry that I'm making them dumber, that I'm like shrinking their little hippocampi before they even have a chance to learn. And I sort of worry, what's the effect on society if we do this with the skill of knowing stuff as well? You might say, well, it's better, Nowadays, if you want to know an answer, it's at your fingertips. You just Google it on your phone, and we're living in a golden age of knowing stuff. That is true. It is nice when I'm having some annoying tip-of-the-tongue kind of thing. Oh, what's the name of the bassist in that band, It's nice to be able to pull it out and just be able to have that instant gratification. Or if you have kids, like I have little kids. Just yesterday, my son was like, so when I'm swimming in the water here, we were in Hawaii last week, I took a red eye in just to do this. He's like, when we're swimming in the water here, do I weigh more or less than I do on the moon? And I was like, wow, human buoyancy in seawater, normal force versus gravitational constant, I don't know. This is the kind of thing where you just, 10 years ago you had to lie to your kid. And if you have kids, this is not an occasional thing. This is like several times a day. And now you can actually answer. It's great. But there are benefits to having the facts in here instead of here. There's a benefit of volume, for example. To make an informed decision, you might not need that one fact, the name of the bassist in that band. You might need hundreds of facts. If I'm going to have an informed opinion on U.S. foreign policy in order to vote in an election, there's going to be hundreds of things I'm going to need to know about the situation in Iraq, not just one. Hundreds. And there's good evidence that a majority of U.S. college students cannot even find Iraq on a world map. Like, really? These are the people we're going to trust to do the hundreds of Google searches required to get an educated opinion on how they're going to vote? Like, I don't know. Like, wouldn't it be better if more of that stuff was in here and less was on the smartphone? The other advantage would be one of time, I think. Sometimes decisions are time sensitive. The story I always think of is a little British girl named Tilly Smith who was on the beach in Thailand, Phuket, Thailand, with her family in 2004, I think, late 2004. sort of important to the story. And notices the sea level is dropping. As her family's playing on the beach, she notices the sea level is dropping rapidly, and she's starting to see bubbles far out to sea. She runs to her parents and she says, Mr. Kearney said that this is what a tsunami looks like. This is the first warning of a tsunami. And they're like, who's Mr. Kearney? It's her geography teacher. This 10-year-old girl had just done a class project on tsunamis. She's like, we got to get off the beach. Her parents are like, are you serious? And she's like, yeah, this is what a tsunami looks like. This is what Mr. Kearney said. So she tells her parents tell the lifeguards, hundreds of people leave the beach. This is the day of the Indian Ocean tsunami in the day after Christmas 2004. So hundreds of lives are saved because this little girl had access to the right fact at the right time. You know, it's a little bit macabre, but probably accurate to imagine her dad Googling, like, what does it mean when sea level drops, you know? Like, that's sort of a big difference in outcome there. So I guess the ultimate question is, to what degree do I welcome our new computer overloads? It's very hard to do, by the way. If you're going to make a joke in Final Jeopardy, like, try to pick a shorter one, because the light screen's sort of small. You only have 30 seconds. Harder to do than it looks. I just want to get better appreciated for my penmanship here. It's a difficult question, On balance, yes. I mean, it's easy to complain about, whatever our, the stand-up routine beef with technology is, the, TiVo that's hard to program, or the customer service that takes an hour to get a simple answer. We forget about the invisible ways in which technology, very much blesses our lives. If Watson's going into healthcare, that's not just for PR. That's because lives are going to be saved if diagnoses are better. After the match, I had not been allowed to talk to anybody from the Watson team before the match. So after the match, I was surrounded with a suddenly much friendlier group of, and I think the scores helped. Suddenly much friendlier group of engineers, thanking me and congratulating me, and they were very effusive. Somebody told me, do you know the story of how Watson started? We were in a bar just having dinner or something after work, and one of your games came on TV, and the whole bar emptied, and that's when Watson was born. Watson was a result of these guys watching me on Jeopardy. So there's this whole sort of Frankenstein thing where I produce the air that eventually kills me. And it's worse than that. Some other engineers told me, there's a lot of you in Watson. We watched your games very closely. I later learned they had played millions of games in simulation against Ken Jennings, against some simulated me. The better to be able to defeat me in real life. Again, that's what it looks like when the machines come for you. And I guess I could have been creeped out, but I felt flattered. It sort of reminded me that in the end, and I'm sure this is the spin IBM likes too, so if they were gritting their teeth through any of this part will be better, guys. It was human innovation that won. They had sent out 2 banner ads for my approval that were going to appear on their site, depending on whether a human won, a carbon-based life won or silicon-based life won this game. And the headline in both cases was "Humans win." Human innovation triumphs, Watson wins, or "Humans win." Actual carbon-based life clings to its Jeopardy advantage for another year. And it sort of reminded me that, that is a good point. We need to be aware of the risks. We need to be aware of why people are scared of what could be coming. We need to soften those edges. We can't pretend it doesn't exist. And, in our dreamy utopia, all this will be fixed. So la, 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 la. We need to engage these issues. But, I do welcome our new computer overloads. Maybe it's because I was a computer science guy before I went on Jeopardy and was able to get, a job I actually liked a little more, but I was a computer programmer in a past life, and I was just fascinated by Watson. It was like a miracle every time it answered a question. I was like, make it do it again, Maybe not so much during the game, but certainly in simulation. So I do welcome our new computer overloads. It was definitely a once-in-a-lifetime experience, and one that I am very lucky to have had. I do have a few minutes left for questions. Thank you so much for listening. Does anybody have a...
We've got a little over 10 minutes, so let's see how many we can get through. Do it Jeopardy style. Where's the mic on this side?
I will not be answering the form of a question.
Okay, starting kind of back left near the aisle.
Nick Beckstead from Giving What We Can. We're a group that promotes giving to highly cost-effective charities. And you gave your winnings from the Watson match to Village Reach, which is a group recommended by GiveWell. I'm a big fan of them. I was wondering if you could comment on what led you to that decision and how you think about giving to charities.
It was a great opportunity. I have tried to play game shows for charity in the past. Because when I was a kid, you'd always see these 80s celebrities on game shows, and I'm playing for Cedars-Sinai or whatever. Oh, look at these great humanitarians, you know. Loretta Swit is on Family Feud, and she's playing for charity. This is so great. I aspired to that. But I tried to do that when I was on Are You Smarter Than a Fifth Grader? They said, when Jeff Foxworthy asks you what you're going to do with the money, what are you going to say? And I said, well, I'll probably go to charity. I mean, I'm doing okay. And they're like, it's not really so relatable. What if you say you want a new kitchen? You know, apparently giving to charity is not a friendly middle-class thing to say on network TV, which I thought was a tragedy. So when Jeopardy told me our idea is that half the winnings go to charity, I was very excited, and then panicky because how do you choose? You know, so many worthwhile causes. I am a former computer programmer in a past life, a bit of an efficiency wonk. I wanted to make sure the money was used well, you know, solving the most urgent problem and not going to, crazy, luxuries and, out of proportion overhead and stuff. And and I found these rankings called GiveWell that were very helpful. And one of the sites they led me to was actually a local nonprofit in Seattle, so local to me, doing work for global health work in sub-Saharan Africa, so you can't really say it's not important. Like kids' lives are being saved by these vaccines. And they were doing something sort of wonky as well. They work on supply chain stuff, how to get the vaccine to the most remote villages, which is apparently the hard part of the problem. It's easy to get it to the capital of Mozambique, very hard to get it to these little remote mountain villages. So this really appealed to me. I met with the guys, they were great. And it was a privilege to be on Jeopardy and look likable for a change for two reasons. One, you're playing, again, the evil supercomputer instead of sympathetic humans that are having to play the 70-time winner. And second, you're giving your money to sick kids. So it's win-win.
Next question in the back, on the right. All the way in the back.
I think you had said that in the games that weren't televised between you and Brad and Watson, that you won one and Brad won one. So the one that was televised just happened to be one that Watson won. So what happened?
The decision was not made after the fact which one to televise.
Exactly. So
there had to be, there had to be practice games for us to see the machine in action, for the crew to see how they were gonna, taking Jeopardy to a research lab in upstate New York is sort of difficult. So it was a rehearsal for everybody. It was very clear what the rehearsals were. Watson was playing according to a slightly different gameplay engine, which may have affected the outcomes. But the fact is there's just a lot of chance in a Jeopardy game. Who finds the daily doubles, how much they wager. Sight unseen, is that going to be an easy question or a hard question? There's a lot of chance in every Jeopardy game. You knew why the IBM guys were sweating. I had dignity on the line, but I had not been writing 7 or 8 figure checks to make myself better at Jeopardy like perhaps they had been.
Michael Vassar, president of the Singularity Institute, in the aisle.
So, Ken, thanks so much for coming, and there are so many questions I'd like to ask you, given that you're good at answering so many questions. But the one that I'm really dying to ask is, was your kid more buoyant or heavier?
The answer seemed to be less in seawater. I did not look up the freshwater. Like you're lighter in seawater than you are on the moon. Somebody want to double check my math? That was what I figured out. But yeah, if that comes up on Jeopardy, I don't know if I would be confident enough to buzz.
Looking for a hand?
All right, punch over there.
Here we go on the right side. It's coming to you. Yep, you. There's the mic.
If you could plug into Watson directly, would you do it?
If I could plug into Watson directly. I see. So I still maintain my human consciousness, of course, but I have the benefit of its text search and question answering properties. Absolutely. I mean, we're talking about the time sensitivity of information. I mean, this takes a while, especially if you're in Midtown Manhattan trying to get an AT&T signal. The immediacy of having that fact spring to mind is great. So I guess what I am implying is, yes, in some distant future where we all have the chip in our brain, we will not need to accumulate stuff. But I don't know, is that going to be good for our souls? What about our thirst for knowledge, you know? Like, don't we appreciate a fact more if we remember how we learned it, if there's a series of emotional responses that come with it? It's not the same thing, I think. But yes, I would rather have the wire than not.
Toward the back, near the left aisle.
Hi, did you have a sleep, diet, or exercise routine to maximize your performance during gameplay?
Sleep, diet, or exercise? I think I did have more of one than Watson did, but still not very much. I remember what really helped on Jeopardy was it was just headspace thing, getting into a routine, always having the same pineapple off the fruit tray every morning, you know, sort of getting muscle memory working, I guess like a baseball pitcher, you know, with a series of rituals. You know, I didn't wear the same jock on Jeopardy for 75 straight shows or anything, but I'm not a superstitious person, but I did sort of like that sense of routine and you know, just getting into the game phase. That said, I can't recommend some specific tofu and quinoa dish that will make you win 75 times on Jeopardy. I'm sorry.
Okay, well, we'll do one over here on the right and then one down here in front.
Since you were one of the greatest things that happened probably for Jeopardy's ratings in years, did you get to be close friends with Alex?
Me and Alex. As I was sort of implying during the speech, you don't get to hang out beforehand with anybody who knows anything about the game. It's not just a good idea not to cheat on a game show in America, it's still it's a felony, basically. There are still laws on the books from the 50s quiz show scandals that make it a felony to rig a game show. I would go to jail. So as a result, Jeopardy takes this very seriously. Contestants are kept sequestered at all times like a jury, trooped around together like a chain gang. If one person has to go to the bathroom, everybody gets up and goes to the bathroom. And so you don't meet Alex beforehand. You see him when he steps out, you know, at the top of the show, and that's it. You get a picture with him during one of the breaks, and that's about it. That said, if you can arrange to stay on Jeopardy for 6 months, you do sort of get some sense of the guy. It's not like we go bowling together or anything, but we're friendly. He's a lot looser and funnier in person than he seems on TV. The stuffed shirt thing he does is sort of for the benefit of the game, I think. In person, he's more prone to jokes and crazy accents and little bits of soft shoe. And the comparison I have made before is that he's more like he's not like your drill instructor type dad, your great Santini type dad. He's more like your sort of goofy, slightly losing it grandpa. And probably more so as the years go by. He turned 70 this year. So he's not at all like what he seems on TV. And yeah, I did get a sense for him as a person. And I've seen him a few times since then, and he's always been Alex, but he's been very kind.
Did you hear from Garry Kasparov?
I have not heard from Kasparov. You know, I just realized. Sorry, go ahead. Do you have a follow-up?
No, go ahead. I do. Go ahead.
He was IBM's previous victim, and probably would not have been at an event like this. Maybe I don't think he was so taken with the sense of wonder of the experience as I was, from what I've read.
He described it as a wall coming at him, playing against Deep Blue. Can you sum up the feeling, the affect, the sense you got from
There is the similar sense that you are facing Terminator. You know, it does not get cocky when it's up. It doesn't get depressed when it's down. It never gets overconfident or underconfident. It always coolly decides whether or not it's going to buzz, and then makes the perfectly timed buzz, and it just is going to keep coming. And if you cut off the arm is going to keep coming. Like you did get the sense that it was just not going to let up, you know, that it was the perfect player in many senses. And I just realized, reading an article about Kasparov recently, that I sort of made one of the same mistakes as he did. I know people say he came out and played all these weird openings, you know, in hopes of confusing a machine player. The machine took him off his game, and he tried to do crazy stuff. And I didn't do anything that crazy, but I remember early in our TV match, you know, thinking, anytime I'm going to get in, you know, if I have a reasonably good guess, I'm going to be buzzing a little more wildly than usual. You know, I'm going to be swinging away here, because I sort of need lucky guesses. I need to find daily doubles. I can't win without aggressive play. So I played more aggressively than is my taste, and it sort of backfired. I got down early on a couple big dollar value questions where I sort of had a 50-50 chance and guessed wrong. And yeah, I sort of made the classic Kasparov mistake. So next time you are involved in a competitive activity against a bajillion-dollar evil supercomputer, please, whatever you do, don't let it take you off your game. You know, do your what? I don't care if it's lawn darts or Battleship, whatever you're playing. Just play your game. Don't get psyched out.
Time for a couple more. I'm looking for the mic over here on the left side. Okay. Do you have the mic? Wait for the mic. Here it comes.
What is the craziest and/or stupidest question that you've ever been asked on Jeopardy?
Craziest or stupidest question asked on Jeopardy? I mean, you guys ever watch the interview segment? I mean, I like Jeopardy, and I TiVo through that thing. It's cringeworthy. I remember Alex just one time springing on me. When the format is not made for being on 75 times. You can't do 75 of those little mini interviews and still, you know, have anecdotes. You know, you run out of real anecdotes in a week. You know, and after that, it's just sort of semi-made up stuff. Alex would be like, "So it says here you sort of like airline food, Ken." Yeah, that's right, Alex. There's really no story here, but I sort of like airline food, you know. And I remember him just sort of getting fed up with this particularly challenging part of his job, you know, because he wants to get out of there. He's got Laker tickets. He's just a guy with a job. He wants to get out of there. And I remember him asking, just without any warning that he was going to do this, "Hey, Ken, what do you want to ask me?" And I had nothing. I was like, "What did you eat for breakfast this morning, Alex?" And it was some terrible answer. It was like a bowl of Trix and a Mars bar or something, you know. It was some terrible example for America's children of what you would imagine to be Alex, you know, starchy Canadian constitution.
On the right aisle, up toward the back.
You mentioned you aren't a futurist or a technologist per se, but do you feel strongly about any of the trends that have been indicated by, say, the presenters today or whatever's being proposed by mainstream media?
You know, I'm fascinated. You know, as futurists go, I'm an enthusiastic layperson. You know, I guess I don't have a particular area of expertise. If I did, it would be AI. You know, this is why I was so amazed when I got this phone call, because, you know, I'd grown up reading Hofstadter's books about consciousness and artificial intelligence and, you know, the philosophy of the problem and, you know, how do we tell when a machine is conscious? You know, does it make it conscious if it can do the things we can do? You know, it's the Chinese room puzzle. Is it actually doing these things, or does it just look like it is? You know, obviously, you know, the Watson competition did not quite get to that level of philosophical interest. But if there's one part of the future that does fascinate me, it's these information technologies. You know, what's it going to do to us? Are we going to be? Is it going to change us? Is it going to change them as they get better and better? You know, what happens to society then? I have no answers. I'm skeptical that there is some big paradigm-changing thing that's you know, some finite number of years away. I sort of feel like these kind of things are always incremental, and there tend to be plateaus. You know, just when you think processor speed's always going to keep going up, or you know, space travel is just going to keep on, you know, then you hit some plateau of physical limitations or complexity or whatever it is. So I'm skeptical of pretty much everything this summit is about. No, I'm just kidding. I'm skeptical of some, you know, rapture-like singularity moment, but I'm just fascinated. I can't wait to see what's next.
We've got time for just one more question right here in front.
This is going to be the last question of the whole summit, by the way. So, like, no pressure. This has to be better than all the other questions put together.
No pressure. So, Jared, Geico has the gecko. For a commercial deal with the commercialization strategy.
You know, it's funny. He's asking if I should become some IBM pitchman now after having become its whipping boy and little Terminator eyesight target. You know, don't you want to be in the ads now? The funny thing is, the first time I was on Jeopardy, that is how it worked out. The question I lost on was about H&R Block. I said FedEx. Within a week, I had like offers from both H&R Block and FedEx, you know, to do advertising for them. So if you're going to lose on Jeopardy, lose on the corporate question, you know. If the answer is like, who is Isaac Newton or what is Uzbekistan or whatever, you're not seeing a penny. But that said, no, I think Watson. I got the impression that you know, the Jeopardy thing was. It wasn't a red herring, but it was a media circus for Watson. That's not what it's about. Watson was not built to win on game shows. I'm sure. There have already been computers that could play Wheel of Fortune at near human levels, you know. you know, the interesting thing about Watson is the questions it can answer, not the game shows it can win. So I get the feeling that Dr. Ferrucci's team has looked past game shows long ago. Sadly, I cannot say the same. I am still stuck with my first love, the pathetic carbon-based quiz show, and you know, long may it prosper.
Ken Jennings, thank you so much.